All right, this lesson we are talking about something called polar coordinates. And I first want to talk about coordinates we already know, which are the Cartesian or rectangular coordinates. So we're used to seeing an XY plane like this, where the position of a point is based on the horizontal and vertical movement and where those two things intersect to make one point. And we generally represent that generically as X and Y, and it's based on where the horizontal position and vertical positions overlap. And those are called rectangular coordinates. You might see it sometimes called Cartesian, based on the mathematician's name Descartes, who formalized that coordinate plane. So another way of identifying this point in space is using distance and an angle. So that's the ones we're going to be talking about today. I could also draw this vector, and that represents the distance from, in the Cartesian plane, this 0, 0 is the origin, and what we're calling it in polar terms is the pole right there. So this distance from here to here is one part of our ordered pair, and then this angle that goes from here to here is the other piece of identifying information. So this distance here we're going to call r for radius, and then this angle here we're going to call theta, and this right here is our polar axis. So two different systems that serve different purposes, but both can be used to identify this point in space. And as an ordered pair for the polar coordinates, it's r first and theta second. So what we're going to do first on our notes is practice identifying where a point is on a polar coordinate plane. So I'm going to take a minute and pause the video. I'm just going to label this the way we would label a unit circle, so I'll be right back. All right, I've labeled this plane with unit circle, radians, and a few degrees. You might want to have a unit circle handy. We used this one in class today. So I've labeled this grid with pi over 6 in simplified and non-simplified terms, because I wanted to drive home that each of these straight marks is 1/6 pi. So I have 1 over 6, 2 over 6, 3 over 6, 4 over 6, 5 over 6, 6 over 6, and so forth, and then I've simplified where appropriate. So that way, the reason why I did that, so if we're counting a negative angle, remember, goes backwards, or positive goes this way, that you know how to count. And then in the first quadrant, I labeled the 30 degrees, 60 degrees, and the 90 degrees. And one quick thing I want to remind you, because it's been a few units since we talked about the unit circle, if you're given a positive angle, remember that you start here on this axis, and you're going to count in the counterclockwise direction. And if you're given a negative angle, you're going to go in the clockwise direction. So I just wanted to remind you of that. And you'll be starting on the polar axis before you begin going counter or regular clockwise. All right, so here is how we are going to graph these points. So we have a r for, by the way, that is for radius. So because if this point was moving in space and this was the fixed distance, it would create a circle, and that would be the radius of the circle, right? And that's how that That's how we can define that distance is a fixed distance and creates a fixed point. So one thing that's going to help us graph these is if we determine the angle line first and then graph the radius distance second. So on our graph here, let's find 4 pi over 3, which is right here. Right, so we start at the polar axis and we go, our angle goes this way to here till we get to right there. Now my radius is 3, so if you notice we have these circles. This inner circle has radius 1, this next one is radius 2, the next one is radius 3. So if I'm trying to end at this angle with radius 3, I'm going to count 3 circles. So 1, 2, 3. So here's my point P. Right there. So that is A 3, 4 pi over 3. All right, so that is a polar coordinate where the r is positive and the theta is positive. So in this next example, the theta is negative. So we're going to determine the angle line first and the radius distance second. So negative pi over 6, now that's negative, so we're going to go clockwise. We start at the polar axis. A negative pi over 6 is going to go down 1/6. So that gets me at this line right here. And my radius is 2, so I'm going to go to the second circle. So this right here is where my next point is. So that's point B, 2 negative pi over 6. And then our C point, now what is happening is we have a positive angle and a negative R value. So this is going to be an interesting difference, but from A and B. So, but again, we're going to start with our angle first, 7 pi over 6. So starting at the polar axis, that's a positive angle. We're going to go counterclockwise till we get to 7 pi over 6 here. Let me get a different color. So here's 7 pi over 6. Now, if this was a positive 5, my point would be at the 5th circle. 1, 2, 3, 4, 5. It would be here on the 7 pi over 6 angle. But it's not a positive 5. So negative 5 means we need to go on the same angle line, but in the opposite direction. So here is my pole. That angle line that is the same as 7 pi over 6 extends this way to positive pi over 6. So negative 5 is going to be 5 circles in that direction. So 1, 2, 3, 4, 5. So right here is negative 5, 7 pi over 6. And then this last example has both things being negative, and the angle is now in degrees. So that's negative 240. So we're going to start at our polar axis. Negative is going to go in the clockwise direction. So this is negative 180, then negative 210, and then negative 240 is right here. So from here to here is negative 240. Now, if this was a positive 4, I would just count 4 circles, and my point would be here. But since it's a negative 4, what I'm going to do is extend that angle line this way to 10 pi over 6, or sorry, 5 pi over 3, and count for that opposite direction. So 1, 2, 3, 4 right here. So that is point D, negative 4, negative 240. All right, so the point of that was just to get us sort of more of an intuitive understanding of where points are in the polar coordinate system. What we're going to do now is algebraically convert from polar coordinates to rectangular, and then from rectangular to polar. So if we're converting from polar to coordinate, that means that we are starting with something that's in this form, a radius and an angle measure, and we're converting it to XY, a horizontal and vertical measures. So what we're going to do first is just do a quick derivation of the formulas that we need. So imagine that we have this point P on a circle. Here's my origin, right? So here's the point. This has both rectangular coordinates and polar coordinates, okay? We're going to be given polar and we're converting to rectangular. So here's my generic triangle. This is my horizontal distance, my vertical distance. This is the radius from the pole to the point, and then this is the theta created by that point. So cosine of theta is going to be adjacent over hypotenuse, so that's x over r, and sine of theta is going to be opposite over hypotenuse, which is y over r. Now, if we were to solve both sides and get rid of that r in the denominator, I would multiply both sides by r, and that's going to give me r cosine theta equals x. And the benefit of this form is that I have x solved for in terms of r and theta. So everything on the left is the polar information and everything on the right is the rectangular. That's going to allow me to convert between forms. Same thing with the sine function. Multiply both sides by r. These cancel, and I'm left with r sine theta equals y. So now I can figure out what x is, and I can figure out what y is as long as I already have r and theta, and I just plug them in. And so that's what we're going to do in this example here. I have my radius 6 and my theta 11 pi over 6. So to figure out my x coordinate, I'm just going to plug in 6 for r and 11 pi over 6 for theta. Take a minute, pause the video, go to your unit circle to figure out cosine of 11 pi over 6. It is square root of 3 over 2. So the 6 over 2 simplifies to 3, giving me 3 rad 3. There's my x coordinate in the rectangular system. So y is 6 times the sine of 11 pi over 6. So pause your video and go figure out the sine of 11 pi over 6. And that is going to give you negative 1/2. Multiplying that is negative 3. So my final answer is my x coordinate that I calculated and my y coordinate. So I'm going to pause this here. I'm about to run out of time, and I'll make a new video for the bottom half of those notes.